All right, so we're recording.
Yeah,
How'd everybody do on your exams? Did you get them done in time and stuff?
yeah,
Yeah.
wasn't so bad.
Zach,
Although
did you?
that whole three-digit significant thing was kind of, I don't know. I didn't like it. I didn't like putting a 33, a whole number on there, and then adding three zeros to it.
I had the same issue. I ended up adding 3 digits, just 3 zeros,
Yeah,
because it looked, later down in the test, they had a table and it had all 3 zeros in place. So that's how I did it. But
well, the first question at the top in big fat letters said,
yep,
two three digits
yeah,
or else.
yeah. But I had the same issue. Does that mean 3 digits after the whole number, or
Well, yeah, that's what I did, but I didn't like it anyways.
yeah? Yep, had the same issue. Does anybody have any questions from the exam or anything you want to go over, or should we just jump in the homework?
I'm good. We can just jump in homework if
All right. By the way, has anybody heard from the other Jared?
not me.
Neither way. Okay. All right. Well, let's start on the homework there, and so I'll start on one. Which hypothesis between the null and alternative hypothesis is the hypothesis of no effect, or no difference, or status quo, or is assumed to be true, or any one of another half dozen definitions? That's the null hypothesis.
Yeah. Does anyone else think it's kind of weird because nullification is like you know, to do without, to get rid of something to count
Yeah,
it.
that is true. I wonder if they're using null as in zero
Oh, could be
or
that.
or void. I don't know. Yeah, it is a little confusing.
Zero means not. So no does not.
Would it be not? Yeah.
Yeah. So null is like the standard one, right? The when you don't change it.
Right. Yeah.
So no not means no change.
Yeah.
Oh, yeah. Yeah. Good point.
Gotcha. I can do two.
Okay.
Does HA below represent a one-sided or two-sided alternative hypothesis? So it's one-sided because it's doesn't have the not equal to sign. So if it had the not equal to sign, it'd be two-sided. So it doesn't. So it's one-sided.
Yeah. Okay.
Fill in the matrix below. Decisions based on sample conclusion. So on the left side, so it failed to reject null hypothesis. And the rest was it rejected the null hypothesis, or null hypothesis. And the cross section to it is the null hypothesis is true and the null hypothesis is false. So in the first box, if you fail to reject the null hypothesis, that means, and the null hypothesis is true, that would be a rejected. So it would mean that it's a type 1 error.
Okay.
And then if the null hypothesis was false, though, and you did reject it, that means that it's correct. And then if you rejected, or no, I had that backwards. So if you failed to reject, that means that it was a true statement. And so if it's true, then it's a correct statement. If it was false, so you failed to reject it, then it's a type 2.
Right.
And then if you rejected it and it was true, then that's a type 1 error because it was rejected, but you still accepted even though it was true.
Right.
The null hypothesis, if you rejected it and it was false, then that is correct as well.
Okay. I liked the example from the video with the guilty, not guilty verdict. That helped me
Yeah.
solidify it a little bit better in my head. Okay, 4. Jared, you okay taking that one?
Yeah, the level, well, the answer key says the level of significance is a number to be determined if the p-value is small enough to reject the null hypothesis. It is denoted with the Greek letter alpha. It is the probability of making a type 1 error.
Okay. Number 5, write down the formula for computing the test statistic for the hypothesis for a single mean when sigma is known. That's basically the z-score formula, which is the z-score is x over the x minus the mean over sigma divided by the square root of the number in the sample size.
Yeah, hasn't changed.
Right. Yeah. Yeah, that's one we've been working with for at least a week now. All right. Any questions about 5?
Nope.
I can do 6.
Okay.
Define the p-value. How is it used in the hypothesis test? So on the answer key, p-value is the probability that you will observe the sample test statistic you did, or one more extreme, assuming the null hypothesis is true. Okay.
Yeah. So the p-value, that's the same thing we've been working with for a while too.
Yeah.
If the null hypothesis is rejected in a hypothesis test, well, what is concluded about the alternative hypothesis? We have sufficient evidence to conclude that the alternative hypothesis is true.
Okay.
Well, I don't know. Like you could say it's greater than the null, and then get some random data that says it's actually less than the null. So your alternative hypothesis could be false, but answer key says it's true.
Right. Yeah, good point. Okay. So number 8, does anybody have, do you want to go over examples in hypothesis testing?
The temperature of humans. Kind of a reading.
Yeah.
So the average temperature was thought to be 98.6, so that would be the null, and then they'd be testing it. So they didn't know what it would be, so they just said it would not the null. So that would be a two-sided. And then they tested it, and I think it was like 98.2. So it was a little bit less than the null, but I don't think it was significant enough to be to reject the null.
Right. Okay. All right, so we move on to part 2?
Yeah.
Okay, so number 1, the graduate, or the GMAT test is used as an admission criteria in many Masters of Business Administration programs. The scores of the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. So we want to determine the null and alternate hypothesis. So the null would be 529.
Yeah.
And HA. So the key word is improved. So we want it to be greater than 529.
Right. Yeah.
Which is funny because our last couple of homework assignments have been 542.
Right. Yeah. Yeah.
Within a couple of homework assignments, it's changed. So.
Part B is suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the students taking the exam is still 529. Was a type 1 or type 2 error committed?
The type 1.
Yeah, so that means that
So that the null was true, but we rejected
but
it.
we rejected it anyway, yeah. Okay. If the analysis was done at an alpha of 0.01, what is the probability of committing a type 1 error? So there's a 1% chance that there'd be an error.
Okay.
Yeah. Yep.
And if we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease the level of significance. Let's see, if we wanted to decrease the probability, we would have to increase the level of significance. Is that right? Because they're opposite each other? They're inversely proportional?
Sounds good to me.
Okay.
Yeah.
Okay. Somebody want to do 2?
Yeah, I can do it. Let's see.
All right. Thanks, Zach.
A study by the National Association of Realtors reported in 2004 that...
Talking to your girlfriend?
What was that?
Sorry.
Oh.
Accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation is 5, a real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. He apparently selects 15 of his clients. They purchase an investment property and obtains the data shown. Hey Adam, do you want my headphones?
I've got headphones. I'll put them in.
Oh, okay. So design the study. What is the population from which the realtor obtains? Wait, what is the population? Well, it's just the residential real estate. The randomly selected people. Well, investment property.
So the population would be everybody who's buying a second home. Is that right?
Yeah. I was just trying to figure out a way to say it, but it wasn't coming out. How did he sample this population? That'd be random, right? Simple random.
Yeah.
So, what is the research question? Like the null thing? Is that what they're asking? Well, that would be,
what do you want to figure out?
It's not equal to the null.
You wanted
Yeah.
to
So he's
well,
trying.
that's the age is different than the national average.
Yeah, the average. So the null is that it's 47 years. Oh wait. Average person.
Right.
Average age of a person. Okay. So yeah, the null is that the average age of the person is 47 years, and then the alternative is that it is not 47 years old.
Right. So I think that in the answer key, the keyword is different. So if the average age is 47, then is it different from the national average?
Mm-hmm.
Okay.
Basically what it said, just in their dumb scientific mathematical way.
Collected data. Name at least one way the literature could have randomly selected his sample. So he could have, had just a system of he was going to pick every 4 clients alphabetically.
Yeah.
Or he could have done it geographically in his area or wherever everybody has.
But those wouldn't necessarily be random samples. Those would be, one would be a what do they call that? Jeez, I've already forgotten. Not stratified, not
Cluster?
not cluster.
Systematic.
Yeah, thank you.
Oh,
One
yeah.
would be systematic, the other one would be a cluster. So how does he randomly? Does he do a
Well,
program
you
that?
could pick, like maybe like 3 different cities, and then did the same thing. Like I'm going to look through the phone book, and I'm just gonna flip through the pages, and boom, there's one.
Yeah,
Well, it's from his own customer
but it's
database.
from his own database, so he could set up something in his database that just randomly chose a.
So you could
Yeah.
assign
And
numbers and roll dice.
Yeah.
Yeah.
So there's a
Or-
few different ways he could have done
Drew names out of a hat too. Classic. Random.
it. Yeah.
Oh, I remember.
He could get make a grid of all of his clients, and then he could buy a chicken, and whatever the chicken picked, laid an egg on, then that would be one of the people in his sample.
Redneck random.
Yeah, right.
Pulled out a couple of bones, mixed with hound dog.
All right.
Yeah, I took it a long time ago.
Oh, nice. Describe the data, graph the data on a histogram. Oh man, I don't want to do that.
I think we know how to do that.
Yeah,
You plug it into
let's
the.
just like look at it on the answer key.
Okay. So, I mean, we can describe exactly how it would work. You can do it with either the Excel or the SPSS, which I thought it was interesting that the
No, you
exam
can't do
made
it.
us use the SPSS program. I think it was mostly just to know that we.
It's actually a trick question because you can't use SPSS because it's kind of dumb. Due to the difficulty of using SPSS, we could not compute these data. But it looks like it's SV. Looks left skew. We got a mean of 46.7. That's pretty close to 47.
Yep.
Standard deviation of 8. 8.8 variance. Oh, anyways. Check the requirements. Since there are only 15 pieces of data, what will you need to check?
So they want to make a QQ plot to check for normality.
So the Q to Q, is that just the like the curvy line that goes over the histogram?
Yeah.
Oh, so that would not be a normal histogram. So you need a large sample size to make sure that it's what is it called? It's not normal, but it's approximately normal.
Approximate normal, yeah.
Okay. State the null and alternative. We already did that.
Well, let's see. Maybe it is normal because we can't really calculate the rest of the values if it's not normal.
No, we can.
Can
If
we?
it's approximately normal.
You won't get
Okay.
a Z-score though.
But
Oh,
don't
but we did use only 50.
we need a sample size greater than 30.
Sample's pretty small.
Yeah. So, yeah. Like Austin was saying, Z-score.
Well, because we add these numbers, or approximately, at least approximately.
If you go down, you actually have to get the Z-score anyway.
Okay.
Which I think you just do. You just do the equation on.
So the null is it's 47, and the alternative is it's not 47.
Okay.
If its significance be alpha equal to 5.
All right. I guess we didn't even need an answer on that one. So then they want the z-score first. Let's see.
If you get the test statistics, what is the formula used? Recall or test for after writing down the general formula and put the numbers. Show this work. So yeah, just the z-score.
Okay.
Let's see.
Let's see. I've got that here.
700 deviation 8.8. The x value. I don't know.
So let's see. And we want it to be. Okay, my z-score is wrong. What did I do here? So the mean is 46.73, right? And the sample we're looking for is 47. Standard deviation is 8.827. And the sample size is 15. Is that right?
Mm-hmm.
So the z-score I got is negative 0.118. What am I doing wrong? What did you guys get?
I'm trying to remember.
Oh, okay.
Yeah, I'm building it out.
Calculator. Standard 8.8274. And then the x value would be 47. So I got 0.1169. Yeah, I didn't get that z-score. What the x value is supposed to be? 47?
Yeah.
Well, maybe the mean is 47. The x value is 46.7.
Oh, is that? Yeah, I bet I've got that wrong backwards then.
You didn't. The answer key doesn't give you the numbers that it plugs in.
Oh,
Huh.
What is the x minus the, I think x is 47 because we're comparing it to null. And the mean is 47. So this equals x minus the mean, and this equals, all of it will be standard deviation divided by the square root. So standard deviation divided by square root of standard deviation. And this equals this divided by that.
What did you do for your? What did you do for your mean connector? ISB is not that easy.
Does anybody have a value that's similar to what the answer is supposed to be?
Mm-mm.
0.209. I keep coming up with 0.118. Is anybody else getting that value?
I keep getting 0.007.
Oh,
Yeah, I don't know what I'm doing wrong either.
okay. Okay, well, let's see.
I'm getting something completely wrong.
Maybe I can share my screen. What's that?
Well, I can. Oh, I'm getting kind of a number like that.
Can you guys see my screen?
Are you using the 0.05 for the significance?
0.05 as the significance?
Yeah.
What value would that be?
Because the number 3 point says the significant level, the level of significance is 0.05, or alpha equals that. Oh, that's what I'm doing wrong. I'm using one, not standard deviation.
Yeah, so the level of significance, wouldn't that just be, that's the value we're using as a reference against the p-value?
Yeah.
All right, so if we have the z-score, so x, what are we using for x?
I just put 47.
That's what I had for 47, and then the mean is 46.73. So subtracting those two numbers, don't you get
I'm
0.27?
getting 0.118 is what I'm getting.
That's what I'm getting too.
Okay. That's not what the answer is.
Not at all. Do we think the answer is wrong? There's certainly a possibility of
Type 1 error.
that.
Let's talk about that.
I'm going to call it a type 3 error. A whole new level of
You're doing it in SPSS.
Sorry, I didn't hear that.
You're doing it in SPSS.
No, I'm doing mine in Excel.
Okay.
So the other thing, what's the what's the answer for the probability? Let's see. 0.834. Yeah. Of course, if you key that into the different values.
Hey, yeah, so
Wait a minute, I have an idea. I'm going to plug in the z-score into the backwards formula and find out what the x value is.
Okay, no, that's a good idea.
What's the z-score they said?
0.2091.
So let's say it was 47. The mean was 46.7333. 47? I think the mean was. If the mean was 46, it's 48. But if the mean value is 48.575.
Let's try it.
That doesn't make any sense.
Yeah, do some algebra.
Yeah. Oh, yeah. KT square.
You multiply this out and divide by
So we want to find x.
and multiply.
I'm looking at the discussion board. Nobody else has mentioned any problems with the answer.
So let me make a new calculator. Okay, so let's see. Say 46, 8.824. This equals z squared times the standard deviation divided by the square root of the sample size. Okay. Um,
Oh,
what
hey guys,
frequency?
the national standard deviation is 5. We need to use that.
What?
Yeah,
Oh my goodness.
I wonder if that's it. If we change it our standard deviation to 5, does that do it? 0.209.
Huh.
What?
So that's tricky. How do we know which standard deviation we're supposed to use? So describing the data, the only thing that got us was the mean.
Which I feel like that's. So wait, we're using. So we're using the null hypothesis data, and all we're doing is just trying to find the new mean.
Right. And so the new mean is our x value. Does that sound right? Since that we already have a mean of 47 from the...
You got 0.209?
Yeah.
Using what?
Using the mean of 47, the x value of 46.73, the standard deviation of 5, and the sample size of 15.
Yeah, that's what I got.
Okay, x value 46.73333, and the
Yep.
mean 47, standard 5, sample size 15.
Yep.
Why is mine wrong?
Because your z-score is a different equation than regular z-score. Okay, go over here. Using slightly different equation.
Yeah, I changed it.
M5.
Yeah, it's the x value minus the mean divided by the standard 5. Yes, the new standard deviation.
No, you don't need new standard deviation. That standard deviation.
Why?
We haven't used the new standard deviation for a while for this lesson. 5. And we still didn't get it.
Okay. How
Because you don't have a sample size in this one.
change P5 to N5? It's still wrong.
Okay.
What are you coming up with, Jared? What does it show? Or what is your value?
Equals. So equals like two parentheses or you can see. Okay. I just wanted to type in or yes, I don't really see it. I don't know why you're coming out confused. Oh, P5.
P5.
Yeah, you just did M5.
It's still wrong.
No, M5.
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 You need the square root of the sample size. It needs to be O5.
Yes. Oh,
The sample size is 15.
Mm-hmm.
Oh my gosh. Okay. So we got L5, X minus the mean, divided by N5, which is the standard, yep, divided by
Oh,
the
open object. You click this, it shows the box again on the line.
interesting. And another one.
Your thing is just broken. Ah!
So are you using the same spreadsheet that you were using last week? Because you can use the same spreadsheet.
Well, I'm using both.
Oh,
Both.
it's still coming up weird.
Yours is working wrong?
Yeah, mine's working.
Let me
I don't know.
see yours is mean 46. Well, I put my mean as 47.
Yeah.
Let me see, make sure that mine's correctly, because I think I switched them. I don't know if that's correctly on mine. I still did.
What,
No, I did.
what's the answer you
Oh, no,
usually
no,
come
no,
up with?
no, mixed up. The X value, the mean is our mean value that we come up with.
Yeah,
our
and the
data.
X value is 47.
The X value is the old mean, or is the known data.
But I just put that in and it's still like 0.207.
.207. That sounds like it might be rounding.
No, I
Yeah.
rounded.
And you have the standard deviation is 5, and you have your sample size of 5.
Sample size of 15.
I'm sorry, 15. Yeah. I was just testing you there.
Oh my gosh. Ah.
Can you share your screen? We can look at it.
Yeah. Okay, here is what's going on. Ready?
Yeah.
Click that out right now. See which one's the one.
So, in this far end green spot over here, we have let me just look at my formula again.
So you have 47. Okay.
What if I do this and then this? Nope.
You're giving up, Brent.
Okay. I'm gonna just like redo this. This equals parentheses x minus mean close parentheses divided by open parentheses. So we got the standard deviation divided by the square root of the sample size. Yep. And then so I close out the square root bottom, so I need one more for the whole thing.
I have no idea how.
Wait, so what does that say? It says 20655?
Yeah.
Yeah.
Rounding error.
Why is it 206?
This is upside down. It's an upside down 9.
Excel is just.
How could it be wrong?
What if I open a new file? Maybe I'm just like screwing up my Excel file.
Is this the last question?
So mean of 47 and 46.7. It's bad that I have these numbers memorized. I've done this so much. And then 5, and then 15.
Wait,
There it
what
is.
if you change your sample to 46.73 and just round it to 2 decimals?
Around your sample?
Oh. Is that what you did?
Well, I don't know.
Mine's
That's what mine is. Mine's rounded to 2 sample. Well, no, that's only 2 decimals there.
Oh my gosh.
Is that it?
Yeah. But that's not what we got. You're never supposed to round until you're done.
That's right. That's what the test said. Bolded,
I was
highlighted.
right the whole time, and everyone thought I was crazy.
Do not round until the very end.
If you weren't before.
I wasn't crazy, but no.
Well, that's fun.
Okay, well now that we know this for sure how to do it, some brains now,
Okay. Complete the p-value. We can do that.
Yeah, p-value
Oh.
is 0.834 and
Yeah. So we highlight the blue on the other side because we want to know if it's greater or less than, basically not equal to.
basically probability that it's not.
So that makes sense for the p-value. Compare the p to the level of significance to the alpha. P-value is greater than the level of significance, which is 0.83. Okay, yeah. Because 0.8, our probability is greater than 0.05, which was the alpha.
right,
So we fail to reject the null.
right. And so the conclusion would mean that we have insufficient evidence to conclude that the mean age is different in this area. Okay, and then
So if the alpha, or if it was less than the alpha, then we would reject the null.
right, because that would be statistically significant.
Okay. State your conclusions in terms of an alternative hypothesis. We have then insufficient evidence to conclude that the mean age. Yep. No. Take action. What action, if any, do you suggest the realtor to take based on your statistical conclusions? Well, based on my statistical conclusions, never round until you're done.
and then you'd be wrong.
Yeah. Or I will take your job because I don't round.
That's right. So he should continue. He should stay the course, right? He's status quo.
Yeah.
Since he didn't reject the null. All right. Should we jump into this quiz?
Let's
I'm
do
ready
it.
to do this.
Yep.
Okay, number 3.
So number 3 is the hypothesis. Which hypothesis involves equality?
The null, right?
So
Yeah,
they're
the null
both
is equal.
They're both the null. And then
Yeah.
the p-value is probability of obtaining a sample statistic at least at extreme as the one of various combination of question 5. One computer is probability. Which hypothesis do you assume to be true? Then no. Right?
Which one are we on? 3?
We're on 5.
Oh, what do we get for 4?
4 is the null hypothesis, because when you state both the equations,
Yeah.
the null hypothesis is equal to
Is equal.
the
Right. Okay,
Yeah.
makes sense.
and then number 5, I got lost.
So when computing the probability, which hypothesis do you assume to be true? You always assume the null is true.
You're
Yeah.
trying to disprove it.
Yeah, you're trying to reject it or not reject it.
Yes.
Right. Okay.
Null hypothesis, HO, is the mean equal to 10. With this information, if we should create which of the following represents an alternative hypothesis for a two-tailed filter? So it's the one that's,
Not equal to, right?
Yeah.
and
And left
In
side
my mind-
is less than.
in my mind, I'm kind of like referring to the normal distribution applet thing.
Yeah.
How there's two tails on it. If you like right skewed and or not right skewed, left skewed, but you're taking the two tails of it.
Yeah.
Okay. That's if it's not equal to. It's everything but. Okay. Which of the following represents an alternative hypothesis for the left tail?
Left tail is less than, right tail is greater than.
So left tail would be less than, right? So 7 is less than 10, and 8 is greater than.
Yes.
Yep.
Alligator chomping 10 and alligator chomping 8. Yeah.
So just read the question. It says which relationship would result in failing to reject the null? So p-value would be greater than alpha. And then 10 is the same thing except opposite. What would result in rejecting the null is p-value less than alpha.
Okay.
So 11, an insurance company is reviewing its current policy rates. When originally setting rates, they believe the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this as information to which of the following would be the appropriate alternative hypothesis?
That would be the average claim is greater. Sorry, go ahead.
Yeah. So yeah, I think you know that one. Which of the following would be the appropriate null hypothesis? Yeah, the claim is equal to.
Yep. All right. The insurance company randomly selects n equals 40 claims and calculates a sample mean of x bar as 1650. Use this information. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes, because the n is high.
Approximately.
I would say no because it's approximately normal.
But they're assuming that the sample is normal.
Yeah, I think they're assuming that it's normal.
Is it?
Because, like, I mean, I think they're saying that they can calculate on normal distribution.
Yeah, I was thinking they can follow the rule of normal distribution.
All right.
And yeah, and the next question says this is justified by.
The large number, law of large numbers.
Yeah. Which, if there was no, then you can't
Yeah.
justify anything.
Okay. Which of the following is the test statistic?
What does Z mean?
I think.
Where is Z?
You don't have Z?
Yeah, it's on there. For me, it's the second one.
Second one for me too.
Yeah, so is that what we're choosing? Is Z score?
Yeah.
Okay.
The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40, and the store manager suspects that the average has decreased. She sets up a hypothesis test. So the null is 150, and the alternative is that it's less than 150. He will use a level of significance of 0.05. He then takes a simple random sample of 36 sales receipts from her store and computes 144. Let's see, use this information. So what is the Z-score? Well, it depends. Are you going to round?
I got it.
Okay,
I got the Z. Does someone have the applet up?
I can get it.
I have the applet up, yeah.
Okay, so I have, with calculating it, having the value of 100 or 150 minus 144 divided by 40 over square root of
Wait.
60.
It's going to be 144 minus 150.
No, because the new mean is going to be 144.
Actually, it won't
Oh.
matter. There'll just be a difference in,
It'll just be the opposite.
yeah, it'll be plus and minus.
Yeah, it'll come up to a negative number, positive number.
Uh,
And then you plug it into the applet. So I got 0.9.
Okay. What's the, where's the standard deviation? Sorry, I missed that. Oh, standard deviation of 40.
40 dollars. Yeah. And if someone wants to, I mean, confirm that while we're plugging into the applet.
Yeah, hold on a second. I'm just confirming that. Yeah, I got 0.9 as well.
Yeah. And the p-value associated with that.
Okay,
So
so,
you plug it in.
and we're doing, let's see, was it less than?
yeah.
So we want just the left side, right?
Everything less than 0.9. So it's going to include the middle as well.
Wait, what? It's going to include the middle box too?
Because 0.9's on the positive side of 0. We want everything less than 0.9 and not negative 0.9.
Okay.
Is that
But
right?
Well, but the sample that we're looking for is something less than 144, aren't we? Or is it less
Yep,
than
and
144?
144 is a point. Oh, less than. Oh my gosh.
Less than whatever the value is, the value of the z-score, though.
The alternative hypothesis is that it's less than 150. So,
So when we plug in the mean, the actual mean of her receipts,
Yeah,
the z-score for 144 is going to be 0.9. So you do everything less than 0.9,
right.
right? And so on the applet, it should be the middle section and the left side.
Oh, okay. I was thinking it was just the left side. Okay.
Because, well, if you just did the left side, that would be negative 9 or negative 0.9. Everything less than negative 0.9.
All right, you're right. Okay, so then the probability is 0.816.
yep, which is greater than 0.05, so we can fail to reject it all. There are two
Yep.
types of errors that can be made in performing a hypothesis test, which one involves rejecting the null when the null hypothesis is true. That's type 1.
Yeah, type 1.
So it was true, but you rejected it. A researcher decided that instead of using a level of significance of 0.05, they will use 0.1, which is following may be true. The probability that the null hypothesis is true will decrease as false. The experiment will be more scientifically valid. I don't know about that. So yeah, either the probability of getting a type 1 error or type 2 error will increase. So basically, he is saying that the null hypothesis is more true than it really is. So I would say type 2 error. Because you'd have a greater chance of failing to reject the null, even if it's false.
Because, well, if
Yeah.
if the significance was 0.01, that means it would be harder to reject it. So you have a higher chance of failing to reject the null hypothesis. But if you true,
That's okay. So if it's a false, if the null is false, but you failed to reject it, it's a type 2. If it's true and you rejected it, then it's type 1.
Oh yeah.
And if the alpha value is lower than the probability that you would reject the null goes down, isn't that right? The probability that you would not reject it goes up.
Because what I'm going to say is that because before we were getting like 0.0 or 0.8 for like our p-value, and that already was failing. And if we're trying to drop the significance even lower to 0.01, then that's even further of like a
Right.
it's even harder to do well.
So let's say that our probability is now 0.04. So if the original alpha was 0.05, we would reject the null. But if we moved the alpha down to 0.01, wait, no, I'm sorry, I'm saying that backwards, aren't I? I'm going to stop talking for a second.
I don't know how to do this next one. Or you just plug that in. Plug it in. It's all part. Yeah.
What's the consensus? What does everybody think?
No.
I think it's a type 2 error. Go ahead.
Yeah. Let's focus on 21. I'm
Okay.
going to submit it, and if you guys want to just happen to
All right. Compute the probability of committing a type 1 error if the alpha value is 0.05.
Yes. So the type 1 error means that the null was true, but you rejected it. So would that mean that you put probability? Oh wait, no. Probability was computed. So yeah, you say 0.05 would be useful, right? And I think you would want to highlight this null. I don't even care anymore. That's false. Okay, try the other way. So,
Wait, what happened?
first of all, okay, that's wrong. That's wrong. That's wrong. That's wrong. Change 14 to central limit theorem.
Oh, wow. Okay.
You're welcome.
The team, Jared.
Well, apparently.
Oh, you know what? That is the central limit there. The larger the number, the more central the mean is going to be.
Sure.
Yeah.
And apparently we were retarded in 16 and didn't do 3 decimals. But 17 is wrong, so I have to assume 16 is wrong anyways.
Oh, boy.
Yeah.
That's the one that we spent like the hour on.
Okay. Well,
No,
if you guys don't,
no, that's not the one. We were doing the $47.
if you guys don't care, you can just change 21 to 0.960. Wait, the probability of committing a type 1 is 96%?
So type 1
Yeah.
means that
That doesn't make any sense.
type 1 is that you rejected or failed to reject.
I think it's 0.05.
It means that you rejected it.
Well, that's what
meaning that
I
your
was.
value
I was thinking it's
then
0.05. You put
greater than 0.5.
I would say 0.05. Just say 0.05 and see what happens.
0.05.
Someone else needs to take a hit for the team.
Go
All
back
right, I'm
to
putting 0.05.
Okay, 14, right?
Go back to the apple.
Wait, what? 14? Yeah, is the central limit theorem. What other ones did we get wrong? Those just 16 and 17.
Yeah.
So we had 4 wrong initially.
Yeah.
Okay. Well, rats. All right. Well, here we go. Here goes nothing. Well, 86. Let's see. Yeah, so I still got
What was 21?
21 is 0.05.
It is 0.05. Okay. I thought so, but I'm retarded in this subject, so I don't know.
So oh, did I hit the wrong button on 18? 18 was fail to reject the null hypothesis.
Yeah.
I just checked the wrong box. Idiot.
Oops. Okay, so we've narrowed it down to 2 wrong answers.
What
We
was
changed
wrong?
21.
Yeah, and I had 0.900, so that's clearly not right.
Wait, 21, did you say 0.05 or 0.050?
I have 0.05.
Okay, so just the 2 digits.
Yeah, I just typed the answer, the A value, exactly like it was.
You guys want to try 16 and 17 again?
Okay, so I'm gonna go back to the go down to this one.
Okay, if the z-score was 0.9, all right. Does
Okay, so-
anyone else want to be brave and test a new theory for 16 and 17?
Yeah, well, let's see. So the historical mean is 150, right? And we put that there.
Wait a second. Did we put in a
So
wrong?
the mean is 150.
And Jared is on.
And then the sample was 144.
Yep. And the sample size is 36. That's got to be a rounding error.
Good count there, yeah, should be.
And the sample size was 36.
36.
So you do it. Yeah,
So I got a
that's
negative 0.9.
Wait, and she wants. Oh, okay. Let me look at this. Maybe that's what we did wrong. Maybe we highlighted the wrong. Where from?
Unless I switch these numbers and I get 150 and then 144.
Probably not.
Yeah, so
Maybe
maybe
either highlight from one or the other.
maybe it's supposed to be negative 0.9.
She suspects the average has decreased, so it has to be everything less than the p-value for 144. So if you use 144 as your x,
Yeah, so x is below the mean, so it
Yeah.
has to be minus standard deviations.
let me see your Excel.
So it's probably negative 0.900.
Yeah, and if that's the case, then your new area is 0.184.
Yeah, because this is what we got, and this was the null. This is the deviation and the sample size. And
Yeah, okay. And then,
so let's try 16 negative 0.900. And we want to know that it's everything is less than that number.
So that would be
So,
0.184, Jared.
yeah. Yep.
So we got that right. 18.
All right.
That's
You falling on your sword there?
Because we failed to reject the null hypothesis, and that was correct.
yeah.
But if we
that-
do it this way, it's not significant enough. Oh, wait, no, it's 0.5.
no, it's still right.
So yeah,
Yeah.
it's greater than
Yeah, it's 0.05. Yeah, still okay.
Okay, so negative 0.900 and then 0.184. Austin
There
and
we go.
Zach, do you want to flip a coin?
Austin.
Okay. Waiting. 100%.
Okay, so 16 is negative 9, or 0.09.
No, negative 0.900. No.
All
We
right.
have it right. What we recalculated is right. Just a minute, get 100, be happy.
0.184.
Okay. Well, that's small comfort, but
I don't care at this point. I still have an A, so suck it, statistics. My average is greater than your score.
at least for another week.
Yeah.
Okay, well, that was fun.
All right. Well,
Thanks,
thanks, guys.
guys.
I'll send you the link, Austin.
Thank you.
Yep.
Yeah, sorry if I'm an inconvenience.
Oh no,
It
you're
means a
not.
lot to me though that you do that.
No, not a problem.